All right, so we're going to find the distance PQ, and then we're going to find the coordinates of the midpoints of PQ. It asks, there's this type of integer or decimal rounded to the nearest tenth addition. So, looking at the directions there, for how I type my answer in, the only way that this is going to be an integer is if when I do the distance formula, I get a perfect square underneath. Otherwise, you're saying don't simplify it. Just take the calculator and evaluate it and round it. Okay. So we should be able to take these values, P and Q. Okay, so P is at 4, 5. Again, I like to write mine on top of each other. Q is 8, -2. If I'm trying to find distance, remember distance is this thing, right? Okay, so now we're going to take our x values. So all this means here is you take your x values and square them, right? And it doesn't matter the order. So I would go 8 minus 4. Okay, what's that give me? 4, and you square that, you get 16, right? We're then going to add to that plus sign. Now take your y's and do the same thing. Okay, so this is where maybe some of us are getting ourselves in trouble. If I go 5 minus -2, minus and negative turns into addition, right? So 5 minus -2 turns into positive 7. So then we'll square 7 and get 49. Okay, add those together and I get roots. Okay, what's 49 plus 16 gives me 65, right? Okay. Now that turns out, if we wanted to simplify that, now I know this question doesn't target this, but it is something to talk about. 65 breaks down to 13 times 5. What kind of number is 13? Prime. What kind of number is 5? Prime. So neither of those are divisors that are perfect squares, right? So if we're asked to simplify it, I take those 13 and 5, and I multiply them back together, put them back underneath the radical together. So what's that telling me? All I'll get is radical 65, right? So radical 65 is already fully simplified. Now what they're asking you to do is to take this and evaluate it and change it to a decimal rounded tenths place. Okay, so I take square root of 65. I get that. Okay, so that's my tenths place, right? So I'm going to write that as 8.1. Okay, because that 6 tells me to round up, correct? Okay, now here's my argument. Is 8.1 radical 65? No. Okay. When I take that decimal, I'll show. I don't know if I showed you guys this the other day. Let me see if I can remember how to do this. I showed one of the classes, but I think it's important that we all see this. When you have a square root and it does not turn out to be a perfect square, like if it was 64 underneath the radical, it would turn into 8, right? And 8 terminates, 8.0. Okay. So then I can write that as an exact value. But radical 65 is a symbol for an irrational number, a number that I multiply by itself 2 times until I get 65. That number neither terminates nor repeats. So at some point, if I want to write down the decimal version of it, some point I would have to cut off some decimals. Does that make sense? So I want to show you what we've got here. If I go like eval square root 65, and we'll just go 10 decimal places. I think that's right. Maybe I go eval f. Okay, so let me zoom in on this. All right, so you see that my square root of 65 would be that number right there, right? But that's still not the square root of 65, because the square root of 65, guys, has more decimal places. Okay, but if I go out to 100 decimal places, Okay, now look at that 4 right there. Okay, maybe you guys can't see it. Let me zoom in on that. So I look at this 4 right there. Okay, I'm not certain whether that should be a 4 or not. Okay, because the computer is rounding that value, right? The next value after that might be a 1, 2, 3, or 4. So it would have kept that as a 4. Okay? But that number could actually be a 3, and the number after it is a 5, 6, 7, 8, or 9. Does that make sense? And it rounds up to 4. So I don't know with any confidence what that value is. So we've rounded here. We've cut off part of my decimal place. That number is not the square root of 65 anymore. Does that make sense? Is it closer to square root of 65 than what we had at the beginning with 10 decimal places? Absolutely. Okay? But this is better. Okay? So now we've got 1,000 decimal places. But it's still not square root of 65. 100,000 decimal places. Okay? You see my scroll over here, it's pretty low. I'm going to be doing that for a long time. Okay? But that number, guys, that number is still not the square root of 65 because I cut off the 100,001st decimal place, right? But it's a better approximation. There is no way for us to write out this entire number. It just keeps going and going and going and never repeating. I think it's probably going to just freeze on me because I don't think my computer's going to be powerful enough to do this. The program should be powerful enough for my computer can't run it. I don't think. So that idea of not being able to write down that decimal, the version of that decimal, all the way. Okay, so length of output exceeds limit. Okay, so this does have a limit of like 1,000,000 or 100,000 or something like that. Your calculators that you guys deal with goes out to 10 decimal places, right? But that's just an approximation for the symbol of radical 65. Radical 65 is in place of what I was just showing you, all those blue numbers on that program. Does that kind of make sense? Okay. And even more than what that program is able to show. So that's the purpose of being able to leave it as an exact value. Okay. When we're in science, when we're working with things that are very, 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 very small or very, 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 very large, we don't like to round our numbers. Okay. Think about if I'm part of NASA or SpaceX or something like that, and my goal is to send people to Mars, do I want to just start using the math that is going to get us there? Do I want to just start rounding things haphazardly? No. Okay. A couple years ago, the UK had a space program, and it was like a $7 billion project. I think it was $14 billion overall, and they were halfway through their program, and it was sending a probe to Mars, I believe. Okay, and there was an incorrect calculation done that deployed a parachute like a fraction of a second too late, and that $7 billion program and that probe smashed right into the surface of Mars. Okay, wasting ultimately $14 billion allocated money. Does that make sense? So we didn't, it was a small calculation error. Okay, but it could have became because of, maybe we rounded somewhere that we shouldn't have, and that rounding value got compounded and affected the time in which that thing deployed a parachute. Does that make sense? All right. Now, if I go to Menards and I'm trying to find, maybe I do some work in algebraic, and I find out that I need radical 65 feet worth of lumber. Am I going to go up to Menards associate and say, hey, I need radical 65 feet of lumber? Where's that at? They're going to look at me like an idiot, right? I said, hey, I need 8 feet of lumber, or I need 9 feet of lumber, okay? So there are times when it's appropriate to have very precise, exact values like radical 65, and then there's times to have numbers like 8.1. Is it okay with everybody? And we have to be able to decipher when those things are, when those situations are. The safest thing to do is always find this. Always find the radical version, okay, the exact version, because then when I want the rounded one, it's just grab my calculator, type that in. Does that make sense? Okay, but I can never go from 8.1 back to radical 65. All right. So just keep those things in mind as we move through. So that gives me that first part. Now the second part says the coordinates of the midpoint of segment PQ. If you remember yesterday, the midpoint formula, m, x sub m, comma, y sub m, that is x1 plus x2 over 2, comma, y1 plus y2 over 2. Okay? Hopefully when you're doing these things, you've got these formulas in front of you. Because now I can just say, this is x1, this is x2. So you go 4 plus 8 over 2, and then this is y1, and this is y2. So that's a 5, I think. Yep. So I go 5. Now plus negative 2 over 2. All right, so 4 plus 8 is 12, divided by 2 is 6, right? And now 5 plus negative 2 is 3. 3 divided by 2 is 3 halves. Now, you just got to be careful. And I've told you to go ahead and work with things in fractions, because if they're fractions, that is the nicest version for other algebra. But it's also the nicest version to say, okay, if they're not asking for the fraction, I should be able to quickly convert it to a decimal. Does that make sense? Going from a decimal to a fraction is harder than going from a fraction to a decimal. Does that make sense? So this question, I look at the blue type, it says type and order paired, using integers or decimals. Okay? Well, 6 is an integer, but 3 halves, okay, 3 halves is neither of those. 3 halves is a ratio. Does that make sense? Okay, it's a fraction. It's not a decimal. Decimal of 3 divided by 2 would be 1.5, right? Okay, so that, if you're missing those, but you put in 3 over 2, pay attention. I get a lot of people who miss these questions because they're not paying attention to that set of parentheses that has the directions and how they want the answer. Okay, is that all right, everyone? Does that help? Any others? 17? Is this it? No? You said there's a graph with it? This one? Okay. So it's a graph. Let me zoom out a little bit so we can see the whole thing. So graph the points, A at -4, 1, B at 1, -4, C at 3, -2, D at -2, 3. Draw a rectangle A, B, C, D in diagonals AC and BD. Find the midpoints of AC and BD. And then it says, what appears to be true about the diagonals of a rectangle? Okay, so this is actually a question that when you guys came into class I had up that we're going to do, but maybe this will take place of that. This is more like an end-of-course exam question, guys. They're not going to ask, they're not going to say, here are 2 points, find the midpoint, or here are 2 points, find the distance. They're going to give you some structured problem, some content that you have to go through a process to analyze and deal with, and then make an argument, make a conclusion about what does the geometry and the algebra that I just determined, what does that tell me? Okay? So if we look at this, it says graph these points. Okay? So again, all you've got to do is figure out, first of all, which one of these graphs are these points. And these graphs kind of stink because they're so small, but -4, 1. Let's look at this one here. Is that all the further I can zoom in on it? Well, this is kind of a pain in the butt, but I apologize for this. So -4, 1. Looking at this, what are my axes moving in? If this is -10, and I've got 1, 2, 3, 4, 5 markings, every mark's worth 2, right? So this here would be, 1, 2. I don't see a -4, 1 from that. Okay. Maybe this is my option here. So 1, 2, -4, up 1 is 1, -4 on there, over 1, down 4. I think that's on there. 3, -2, so over 1.5, and then down 1. I'm saying going over 1.5 of these gray bars, these gray axes or grid lines. So I think C is my option there. Okay, so is that okay? All right. So I think, guys, in getting the picture, that I apologize for that just terrible rendering from Math Excel. But let's do this. Let me go into GeoGebra and let's plot these points and get a better view of what's going on. So A is at -4, 1. B is at 1, -4. C is at 3, 2. And D is at -2, 3. Okay. So again, hopefully maybe you guys are using GeoGebra or using Desmos, that you type them in the same way on both programs, and you're finding that you can construct that rectangle. Is that okay? All right. So now it said construct the diagonals. Find the diagonals. Okay. Well, a diagonal, by definition, we haven't talked about this, but I think in other classes maybe you understand what a diagonal is. The geometric definition of a diagonal is that it's a segment of a polygon that connects two non-consecutive vertices. Okay, what's consecutive mean? One after another, right? Back to back, like Monday, Tuesday, those consecutive days, right? Monday, Wednesday are non-consecutive, right? We skip over a day. So if I look at point A, D and B are consecutive with A, right? So A to C, that's going to be a diagonal. Those are non-consecutive vertices. Okay. What's the other diagonal going to be? D to B, right? Okay. Now here's the question. It says what is the midpoint of AC? Okay. So the midpoint of AC, let me just double check and make sure that is the question being asked. Yeah, the midpoint of AC. Okay, if I look at A and C, we put their values up here. Okay, so just those 2 points. To find the midpoint, we add the x's, right? What's -4 plus 3? -1 divided by 2, right? So my x-coordinate for my midpoint is -1/2. And now do the same thing to the y's. 1 plus -2 gives me -1, right? So -1 up top, divided by 2. So there's my midpoint for AC. Okay? The next question says, can you do the same thing, but do it for B to D? Okay, so look at B and D. And now I'm going to find that midpoint. So let's say BD's midpoint is going to be, add my x's, what's -2 plus 1? -1, divide by 2, right? Add your x's, divide by 2. Now add your y's, divide by 2. And I get -1/2, right? So that's great, that's awesome. But now here's the question. What does that mean? What's the relation that I see about the midpoint of AC and BD? Okay, so this point here, this point AC, or sorry, the midpoint of AC, let's just call it, like the next point that GeoGebra is going to use is E, so let's just call that E. Let me locate it real quick. E at -0.5, comma -0.5, right? And what we're saying here is that E is on the red line, right? Would you guys agree with that? E is on the red line, and E is also on the blue line, correct? That's what that is telling us when we see those 2 points are the same, right? Okay? So -1/2, comma -1/2 is on the blue line, which is the midpoint of AC. It is then also on the red line. Okay? But it's the blue, on the blue line, that point is the midpoint of the blue line, right? And that point is also the midpoint of the red line, correct? Does that make sense to everybody? So the fact that the midpoint is the same on both of those lines, that tells us that that set of lines bisect one another. Does that make sense? If they share, if you have two lines, or sorry, two segments that share the exact same midpoint, that means the midpoint is on both segments. And it also means if it's a midpoint for both segments, then it's going to be one segment is a bisector of the other, and then the other segment is the bisector of the first. Okay? So what's this tell me? It tells me that the red segment is a segment bisector of the blue segment, and the blue segment is a segment bisector of the red one. Is that okay? Something else we find out that's pretty interesting, and we can find these distances. I can click on that distance, A to E, or sorry, D to E, gives me 3.81. Does E to B give me 3.81? Does A to E give me 3.81? And then E to C is also going to be 3.81. Okay? So all four of those smaller segments that get created when these two diagonals intersect are the same. But the argument of seeing that the midpoints are the same tells me that the two segments bisect each other. Is that all right? Okay. If I were to give you, just real quick, this is the problem I was going to give you at the beginning of class. If I go -4, 2, and -1, -6, and then 9.5, comma 2.5, and -14.5, comma -6.5. Okay, if I plot those points, okay, I'm going to create segment AB and I'll create segment CD. I look at those two things. Now, are those two segments congruent? Or can we obviously see that maybe CD is a little bit bigger, right? Okay, but if I ask to find the midpoint of A to B, it's right there at E, right? If I ask to find the midpoint of C to D, it's right there at E again. It put F on top of it, but it's the same point, right? So this point right here okay, that big point right there, E or F, what do you want to call it, is the midpoint for AB, so it shows up on line AB, segment AB. It's the midpoint of CD, it shows up on line segment CD then. And if it shows up at the same exact location in regards to -2.5, comma -2, then it means it's on both segments, and it means it's then bisecting both segments, or it's the midpoint of both segments. So AB bisects CD, and CD bisects AB. Does that make sense? Okay? So throughout the rest of the course, there'll be a lot of situations, especially when we start talking about parallelograms, where we look at this fact. Okay? Because that's a rhombus. If I connect AD, DB, BC, and AC, I develop a rhombus. And one of the key features about a rhombus is that diagonals are perpendicular bisectors of one another. Okay? And that's what we've got going on in this situation here. The quick way of checking all of that to make sure that I do have a rhombus is just to find the midpoint of the diagonals. Okay? And if it's the same midpoint, then I have essentially a rhombus. Does that make sense? Okay? So that's what we're going with or trying to target in that question there. So this will be something that we see again as we move forward. Okay? So I'm not going to finish that, but or at least that specific example, okay? But you see down here when it gives you the option what appears to be true about the diagonals of parallelogram, because that's what a rectangle is. A rectangle is a type of parallelogram. You come up with, I guess this one just calls it a parallelogram. Did the last one call it a rectangle? I thought it did. Yes, it is just a parallelogram. Okay. Does that make sense to everybody? Can we do that? And that's the thing about geometry. Not just so much can we do a formula, use a formula, okay? But once we get results from that formula, can we interpret those results and make an argument, make a case for a particular situation? And that's the math. That's That's kind of the thing that we want to try to target as we go to other courses. Okay, it's no longer just doing calculations, but what do those calculations tell me? All right. Any other questions on here you guys want to talk about? We got time. We can do any one of them. We did okay with the last couple with finding the endpoint. We did all right with these. We'll see one of these tomorrow. Want to do one? All right. All right. So it says the coordinates of point T are 5, -15. The midpoint of ST is 5, -8. Find the coordinates of point S. So S is another endpoint, right? Okay. So right now we know a couple things, and I'm just going to write on top of the problem here that what we know. We know that this is X sub 1 or X sub 2, whatever you want to call it, and this is Y1 or Y2. Okay. It's one of our endpoints, right? This is our midpoint. So I'm going to write that. I'm going to call that X sub M, Y sub M. And what we would be looking for, I've got the completed problem here, but let me change it here. So we've got, what we're looking for then, guys, is X sub 2 comma Y sub 2. Does that make sense? We've got X1, Y1, we've got XM, YM, we're looking for X2, Y2. So, going back off our formula from yesterday, the midpoint, X sub M comma Y sub M, gives us X1 plus X2 over 2 and Y1 plus Y2 over 2. If you remember what we did, I showed you, I think I probably highlighted it for you guys, that and that. This is an ordered pair over here, right? This is an ordered pair. The only way that two ordered pairs can be equal, that's what we're saying with that equal sign in the middle, right? Is if the x coordinate is equal to the x coordinate and the y coordinate is equal to the y coordinate, right? If I give you the ordered pair 3, 2, and I say, give me an ordered pair that is equal to it, what do you got to give me? You got to give me 3, 2, don't you? You got to give me the exact same thing I gave you. Okay? So if I give you, in this case, x sub m, you have to give me x1 plus x2 over 2. Does that make sense? And now you've got some of that stuff. You've got x sub m to be 6. You have x sub 1 to be 6. Okay? I can plug those values in. Do I know what x sub 2 is? We're looking for that, right? How do I solve this equation for x sub 2 then? Multiply both sides by 2, so I get 12 is equal to 6 plus x sub 2, right? Okay, subtract 6 from both sides. Yes, 6 is equal to x sub 2. So right now, this ordered pair is going to have an x value of 6. I then want to find the y value. Okay? So we're going to get y sub m, the y coordinate of this ordered pair, has to be identical to the y coordinate of this ordered pair. Y sub m is equal to y1 plus y2 all over 2. Y sub m is negative 9. Is equal to the y1 is negative 12. Y2 is what we're looking for. Divide by 2. Now, once I do that, if I divide by 2, can I then multiply both sides by 2? My tablet's trying to something it out. Multiply both sides by 2 gives me negative 18 here, right? Negative 12 plus y sub 2. Add 12 on both sides, I get negative 6. Is equal to y sub 2. So now I have the coordinate for that y sub 2. Okay? Now that took some time, right? And this is kind of what I'm trying to get you guys to realize. That formula is nice. It works. It will work all the time. And I'm going to make the assumption that probably number 18, you have to use that formula. But in this question here, what kind of line is ST? Yeah, I did. Which one though? the x values are the same, the y values are different. That'd be vertical, right? So this thing's vertical. So if this thing's vertical, I think about graphing this. If I were to graph this at 6, -12, maybe 6 is right there, -12 might be down there, right? If I go 6, -9, maybe that's that point right there. What's the x-coordinate of that segment's midpoint going to have to be? It's going to have to be 6, right? It has to be on that line. It's going to have the same x value, right? So we're going to have 6 there. So maybe that would have been something that allows you to get this coordinate here a little bit quicker. And if it's vertical, then can we just take, like we did here to find y, take the average of -12 and -9 and divide by 2? Okay? And that will then give me that -6. That's an approach that might save you a little bit of time. Okay? And let me run through and see if everybody's example number 17 would have maybe been the same structure. Okay, so 6, 6, 6, 6. So 4, 4, 6, 6. So no matter what question you got, it looks like you get 6, 4, or 2. But notice that that number right there is always that number right there, right? So everybody, regardless of what their x value was and their y values, was getting a vertical line for this one. Okay? On the next one, maybe we don't. See how the x value here is different than that x value? The y values are different as well. So this is not a vertical or a horizontal line. It's got some slope to it, right? Other than 0, run fine. So then that formula procedure that we talked about in the last question would be the only way you can apply some algebra to come up with this solution. Okay? There are shortcuts. There are things that we want to look at before we start doing the math. Okay? I don't know if I told you guys this yesterday or not, or throughout the last couple days. If you're a person that just does stuff in regular life, don't even think math, don't even think school, you just do things without thinking about repercussions or consequences, are you probably going to be in jail at some point in your life? Yeah, if you do things just on a whim without any thought about what's going to happen if you conduct yourself in that manner, you're probably going to find yourself in a precarious situation at some point in your life. Same thing mathematically, okay? If I don't think about what the problem looks like and what procedures I can go through and the consequences and the foreshadowing that can go along with those procedures, I'm probably going to find myself in a situation where I'm either going to run into a roadblock or I'm going to waste a lot of time doing a problem. Okay? So we want to be thinkers. We don't want to just be a calculator. Okay? Be a thinker first. Okay? Anything else you guys want to talk about on there? That help a little bit talking about that stuff? Okay? If you're struggling, you're going home. All right, so find the midpoint of the line segment joining points A and B. All right? With the midpoint formula, basically what I'm always going to do, guys, is I'm going to look at these and say, are the x values the same? They're different. Are the y values the same? They are different. If they're different, then that means that the line that I'm dealing with is of kind of like that nature. Okay? It's non-horizontal, it's non-vertical, right? Therefore, I have to use the full formula for finding the midpoint. Okay? Even if they were the same, even if both x values were 4, the full formula will work. Okay? Just might take an extra 15, 30 seconds. But remember, the midpoint formula says the midpoint, which has coordinates x and y, is equal to x1 plus x2 over 2 and y1 plus y2 over 2. Okay? So what we're getting at here is if these are the x1 and x2, that's all endpoint coordinates. Okay? And that's why I put the M with these, because a lot of textbooks won't put anything with those, and people get confused. Well, what's that x and y refer to? I put the M with them so we know it's midpoint. So this is my x1, this is y1, and this is x2, and that's y2. Okay? Now, Just like slope, you could have flip-flopped those. You could let this be x2, y2, and this one be x1, y1. Doesn't matter. But when I start plugging those things into my formula here, x1 is 4, x2 is 6, and then I'll divide by 2. y1 is -7, y2 is 1, and then I'll divide by 2. Okay. Now, evaluating those, 4 plus 6 is 10, right? 10 divided by 2 is 5. And then here, -7 plus 1 is -6. -6 divided by 2, -3. And there's my midpoint. Okay. Something you can do if you need to. Okay. Graph A, so 4, maybe -7 is down there. You would want to be a little bit more precise with your location here. I would do B. B is at 6,1, so maybe it's there. And then when I graph C, 5, -3, I would want to see that it shows up halfway between A and B, wherever they're at, and make sure it's on the same segment that A and B is on. Does that make sense? And that's kind of the graphical check to make sure we've done things correctly. All right. I like to use, in that case, I probably want to draw it, guys. I'd probably open Desmos and type in those points, open GeoGebra and type in those points, and it's going to be a lot more accurate. Okay? When you draw your own X and Y axes, you're going to have human error and all that kind of stuff with your intervals. Does it help? Okay, so let's go. So what happens, guys, is my hope is that we get to the point where these questions are almost instantaneous, because it's going to be used a lot later on as intermediate steps in other problems. We need to find midpoints to address other things throughout geometry. So the hope is that we'll be able to look at AB here and say, okay, add my x's, divide by 2. So 12 divided by 2 is 6, right? Okay, so my x coordinate is 6. Now I'm going to add my y's. 8 plus 4 is 12. Divide that by 2, I get 6 again. So my x coordinate is 6, my y coordinate is 6. Okay. If you hear me say, the average of the x's, the average of the y's, that's what we're doing. Add them up, divide by 2. Okay, because you're only going to have 2 x's, you're only going to have 2 y's. Okay, something to talk about, I guess, is this. Just find the midpoint of the line segment joining the points 9, 2, and -3, -2. Okay? Some of you might go through this, and when I do this, maybe I get some values that maybe don't work well together, and they result in like fractions. See, it says type an ordered pair, use integers or simplified fractions, or any numbers in the expression. I have to abide by that because there's something in the background, there's some coding in the background of this program that is looking for an integer, looking for a whole number, positive or negative version of it, or a fraction, a number divided by another number, right? If I put in like 0.5, that is neither of those things, right? So the coding, the programming that's written in the background to adjust or compare your answers to their answers is not dealing with decimals. So if I put a decimal in, it automatically flags that, says that's a problem, this question's wrong. Even though you might have the right work. Does that make sense? Or you might have equal values just displayed in different representation. That's the same thing on the end of course exam. And that's why I like Math Excel, is because it forces you to pay attention to the details. If I'm on the end of course exam and I find the midpoint to be 0.5, 1.5, and they want it as a fraction, and I type it in as 0.5, 1.5, I've done everything right. Okay? I'm a good geometry student. I'm just not very good at paying attention to directions or details, and I get that question wrong, and that may be the one question that makes me take that test again the following year. Okay? So pay attention to those things. They're very, 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 very important. Okay? That's why they change the color. That's why they make it blue, so that it draws your, always shows red, so it draws your attention to it a little bit more. Let's just find the midpoint of this segment. So we're going to take that x value added together, right? What's 9 plus -3? 6, right? You're going to divide that by 2. Okay? Now we'll take 2 plus negative 2. What's 2 plus negative 2? 0, right? I'm going to divide that by 2. So it's going to give me 3, 0 as my ordered pair. Okay? And if I look at this, 3 is an integer. So is 0. So I'm good to go. I've abided by the instructions. Okay? Whenever we see integers, guys, we're talking about these numbers. 0, 1, 2, 3, 4, all the way up to infinity. And their opposites. Negative 1, negative 2, negative 3, all the way to negative infinity. The integers do not incorporate any decimals. So one half is not in that list of values. Does that make sense? It's only your counting numbers, essentially, in their opposite. Okay? Along with 0. 0 is usually not called a counting number, right? We usually call them your natural numbers and not your counting numbers. Okay? Counting numbers are more like a 4th grade, 5th grade word. Okay? Natural numbers is what you're going to see from here on out. For numbers like 1, 2, 3, 4, 5, 6. Alright, so let's talk about this one. So this is, I think, the type of question that people struggle with the most. Okay? It asks us to find, if I give you one endpoint and I give you the midpoint, can you find the other endpoint? Okay, so we're going to look at point T here. What's going on? Just draw a quick picture if you need to. It says point T is at 0, 3. So there, oh, that's not a T. Point T is 0, 3. Okay. The midpoint is at 2, negative 3. So maybe 2, negative 3 is down here. Okay, I'm going to call that the midpoint. They're asking then if that is an endpoint and that's a midpoint, doesn't the other endpoint have to be down here somewhere? Okay. So they're asking, can we find that location? What's nice about drawing the picture is now I know what I've done. To get to that kind of blue bubble down there, don't I have to move from the origin to the right first? So my x value should be positive. And then I need to move down, right? So my y value should be negative, correct? If I go through my work and I get an x that's positive and a y that's positive, I know now, because of the way these points are structured going on, that that's wrong. And I've done something in my algebra that I need to fix. Okay? But the way we do these problems is we have to use the formula. Okay? Especially if we don't have a graph. Okay? I showed you yesterday the shortcut. If you had the graph, and it was a very good, precise graph, but I'm going to use the formula. So I'm going to say the midpoint so here's the logic of looking at that formula, guys. The left-hand side is an x comma y, right? It's an ordered pair. Does that make sense? The right-hand side is a set of formulas that produce an ordered pair. So you got an ordered pair equal to an ordered pair. Okay? Well, the only way that two ordered pairs could be equal is if the x values were the same and then the y values were the same. Does that make sense? So if I give you an ordered pair that's 3, 2, and I tell you, give me an ordered pair that is exactly the same or is equal to it, you have to give me what? You have to give me 3, 2 back, don't you? That's the only ordered pair that's equal to 3, 2. Using that logic then, if I plug in the midpoint information here, okay? The midpoint information, this is my x sub m and this is my y sub m, right? Let's plug that in. Let's plug x sub m as 2 here, and y sub m as negative 3. Okay? We also know that all this stuff over here is endpoint information, coordinates for our endpoints. And right now we have one of those. And I don't care what you call it, either x1, y1, or x2, y2, but we've got that information right here with point t. So I should be able to come over here and say x1 is 0, and y1 is 3, right? That makes sense, everybody? And now use that logic that I said if the left-hand side is an ordered pair, and the right-hand side is an ordered pair, the only way that that equation can be true is if this x value here is exactly the same as that x value there. So we develop 2 is equal to 0 plus x sub 2 over 2. The only way then that the coordinates of the ordered pairs are the same is that these y coordinates are the same as well. So then I get negative 3 is equal to 3 plus y sub 2 over 2. And those should then be two equations that generate algebra in which we can solve for x sub 2 and y sub 2. Multiply both sides by 2. And I get 0 plus x squared, which is just x squared, right? Maybe learn how to multiply. Okay? So 2 times 2 gives me 4. 0 plus x squared is just x squared, right? So that's the coordinate then of this missing endpoint. Come over here. The algebra is the same. Multiply both sides by 2. And now I'll subtract 3. And I get that as my y coordinate, that as my x coordinate. I'm going to type that in and up here as 4, comma, negative 9. Okay? A couple things I've been seeing people is not that they don't know how to do this, they don't know how to set the process up. They get down to negative 6 equals 3 plus y sub 2, and they subtract 3 from both sides, and they get like something like negative 3. Okay? Or they get something like positive 3 or something like that. They have trouble subtracting negative values. Okay? Make sure that we're paying attention to that kind of stuff. And are in tune to that, because you're going through the right processes, which tells me you're pretty good at algebra. It's just that you're struggling with that arithmetic, subtracting negatives and stuff like that. Okay? So if you're missing them, that's something to think about. Is that what I'm doing as a student when I'm missing these? If you've got the work that goes along with this, you can judge that. You can look at that and say, okay, yeah, that's why I'm missing it. Now I can adjust to that. Okay, I can focus on that the next time I see this problem. Okay, I think it's very important as you guys are going through your math classes that obviously the more stuff that you have written down, the more work that you have, and that you can go back to and analyze, the more you're going to learn about yourself, and the more you're going to decide and be able to determine, yes, I'm that person that's struggling with subtracting negatives. Okay? If I do everything on my calculator, when I turn my calculator off, is that stuff all gone? And now I can't go back and analyze that information. Okay? And I really don't know why I messed up. Okay? Which I understand wanting to do things on your calculator. I understand wanting not to write things down, but it's a thing that you got to fight against in these types of classes. Okay, so this would be the same kind of thing. I want to get to one that asks us to deal with. There's a graph. It might have been like question 16 or something like that. Yes, this one. 14. Okay. It gives you these coordinates. It gives you A, B, C, and D. It says draw a parallelogram A, B, C, D in diagonals AC and diagonal BD. Okay. Now we haven't talked about what diagonal is, but hopefully maybe in other courses, 7th grade, 8th grade, you've maybe mentioned these and seen what they are. Once it's the first graph, this parallelogram, the only thing that, and again, this is something with the program, which is again something that is problematic on the end of course exam. If I go through this and I look at those graphs, each one of those graphs goes from negative 10 to positive 10 on both axes, right? But how many grid lines are there from the origin to either positive 10 or negative 10? How many of those little light-colored gray grid lines are there from 0 to 10? There's only 5, right? In each direction. So that's telling me that every grid line is standing in for an interval of 2, correct? Okay. So as we start looking at plotting these points, if I look at this one, okay, I'm looking for negative 3, negative 1. So I would go over, so where my cursor is, that's going over, and I don't know if I can zoom in even any further on this to make it any better. But I'm going to go over negative 2, okay, because it's one block, and then down 2, so that's another block, and that's negative 2, so negative 4. Is negative 2, negative 4 one of my 4 points? No, so that's option A is not what I'm looking for. Okay. If I go -3 again, looking for -3, -1. Well, -3, -1 should be where the tip of my cursor is right now. And that parallelogram doesn't have that point on it. This one does. This one has -3, -1 on it, right? Does that make sense? This one does not. Okay. So my option is C. I apologize for the terrible graphing that this produces or this provides. It is what it is, though. Okay, and it might be something that you guys come across in the other course example. We've got to zoom in and use our technology that way to get a good view of what we're trying to do here. Okay, so I'm actually going to go into, just so we can talk about it a little bit better, go into GeoGebra and plot these points real quick for us. So we got -3, -1, 2, -4, 4, 3, -1, 6. Okay? So it says we got a parallelogram. Alright, so I'm going to connect those AB, BC, CD, and AD. Oh. There we go. So get that shape. You say it is a parallelogram. Okay. Now they ask you for diagonals. Okay. A diagonal is a segment, by definition, it's a segment that connects non-consecutive vertices. Okay, so we got some words in there that we got to kind of talk about. What's consecutive mean? Say again? I can't hear you. Repeat it? Okay. So if I'm talking about like days of the week, like Monday and Tuesday would be consecutive, right? Tuesday and Wednesday would be consecutive, right? But Monday and Wednesday, are they consecutive days? No, jump over one, right? They're not back to back. Okay, one after another. So when we talk about consecutive here, okay, D, if I look at point D, D is consecutive with C and A. Does that make sense? They're right back to back. We're going from D to those 2 points. They're one after another. But if I want to go from D to B, I have to jump over C or A, right? So when I connect D and B, we get that segment right there. And that blue segment is what we refer to as a diagonal. Okay? We should be able to find the midpoint of that diagonal. If you remember, the midpoint of a diagonal, or just the midpoint of any segment. Okay, just looking at these, so these are the 2 points, right? Doesn't the midpoint say add these x's and divide by 2? So take 2 and -1, add them together. You get 1, right? Divided by 2. Now do the same thing for your y's. -4 plus 6 gives me 2. Divided by 2 gives me 1. So if I plot that point, I'm just going to call it M. 0.5, 1. Does that point look like it's the midpoint of that blue segment? All right. So the next question is, can you do the same thing for AC? Can you go to AC and do the exact same thing? Okay, so we're looking at that red segment now. Okay. Well, if I'm looking at AC, now I'm looking at those ordered pairs. Add the x's. Divide by 2. So -3 plus 4 gives me 1. Divide by 2. Add my y's. -1 plus 3 is 2. Divide by 2 gives me 1. Is that the exact same midpoint? Make sense? Okay. So they ask you to do those things. They ask you to come up with those calculations, and I think we should all be able to do that. Okay. But the next thing that they do, and this is the math part of it, guys. What you just did was you were a calculator. You did calculations. You did arithmetic. The math part is the logic and what this tells you. Okay. That point M, is it on the blue line? Okay. Is it on the red line? Is it the same set of coordinates for both? It's the midpoint for both, right? So because it's on both lines and it's the midpoint of the blue one, that tells us that the red segment is a segment bisector of the blue. Does that make sense? Okay. And because it's on the red one, okay, at the midpoint of the red one, it tells us that the blue segment is also a segment bisector of the red one. Okay? So it tells us, and this is what the last question was targeting, when we look at the question. Okay, so what we get? What did we say that was? 1/2 1. Now it doesn't tell me how I got to type my ordered pair in, so I'll just use decimals. Meaning that it's probably got. If I typed in fractions, it would be okay. Let me see if I type in a fraction, if it gives me okay. If there are no instructions, type it in how you want. See how it gives me either way, gave me the right answer? Okay. So the last says, what appears to be true about the diagonals of parallelogram? Okay. So we go through this. Based off of the information that we came up with, the only thing we can say is that the diagonals bisect each other. Okay. If we're using GeoGebra, we can validate that. We can look at A to M as 4.03. That being 4.03. So that means that the blue one is cutting that red one in half, right? It's a bisector. We can look at this one, 5.22, and look at that one, 5.22. The red one is cutting the blue one in half. So by definition, they're both bisectors of one another. Okay? That becomes, there's an entire section of this textbook, okay, of just Euclidean geometry, then we investigate four-side figures. This is going to be a process that we use when we investigate, okay? Because that should allow us to decipher, maybe this thing's a parallelogram, maybe it's a special parallelogram like a rectangle, or a special parallelogram like a square or a rhombus, okay? Figuring out some of that stuff is going to be beneficial when we get to that juncture, okay? Just going over these questions, do we feel a little bit more confident in being able to do this stuff tomorrow? Okay. If I were to ever ask you, say I asked you this question, find that 1/2 comma 1. You guys are able to do it. Find that midpoint. Can I then at the same time say, okay, now find distance dm, find that 5.22? You can use the distance formula, right? You can use point D, because you know its coordinates. And now that you know point M is at 1/2 comma 1, you can use those coordinates inside the distance formula, and you come up with that 5.22. Examples. All right, so this question says the coordinates of point T are 613, and the midpoint of ST is 3, -10. Find the coordinates of point S. Okay, so point S is the other endpoint. Okay, so this is an endpoint. This is a midpoint, and we're looking for the other endpoint. Okay, so that being said, every time I see an endpoint, guys, it is an x1, y1 ordered pair, or maybe an x2, y2 ordered pair. Is that all right? When they give me the midpoint, that's my xm, ym. Okay. Yesterday we talked about this formula, that the midpoint has an ordered pair, x comma m, y comma m, and it should be equal to the average of the endpoints divided by 2, comma, I kind of said that messed up. The average of the endpoints, x coordinates, the average of the y values of the endpoints, okay? Or add your x divided by 2, comma, add your y divided by 2, right? Okay? Now and I don't think we talked about this yesterday, I didn't make this connection with you yesterday. If I look at that, the left-hand side is an ordered pair. Would you guys agree with that? A capital M on the outside is just how I identify it, and that's the letter I'll use for midpoint, okay? The subscripts are just telling me that they are the x and y's that come from the midpoint, okay? So it's an x comma y, it's an ordered pair on the right or left-hand side. On the right-hand side, it's an ordered pair again, isn't it? Okay, but in each one of those coordinates for the x's and the y's of that ordered pair, we got a little bit of a formula, okay? But what we're saying here is, if this is an ordered pair, and this is an ordered pair, and if they're equal, that means the x of the ordered pair on the left has to be exactly the same as the x of the ordered pair on the right, right? And then the y on the left and that ordered pair has to be exactly the same as the y on the right, okay? If I were to give you an ordered pair of like, I don't know, 4, 7, I tell you, find me an ordered pair that is exactly equal to that. You have to give me what? It's the only ordered pair that's equal to 4, 7. 4, 7. Okay? That's the only way that the x's are the same and the y's are the same. So when I say these two things are equal, it produces two equations for us. Okay? Now I'm going to fill some stuff in here. From the information that's provided in the problem. So let me. My tablet keeps freezing on me. Let's see here. All right. X sub m, I know that to be 3, right? Y sub m, I know that to be negative 10, correct? So I'm going to replace those things here. I'll take x sub m, and I'll put 3 right here. I'll take y sub m, I'll put negative 10 right there. Okay? Then I get over here. Do I know what x sub 1 is? X sub 1 is this 6, right? So I'm going to replace that. Okay, now I'm just erasing because I have that ability. Usually if you're doing this on paper, you probably just rewrite this thing again, right? Using those constant values of 3, negative 10, and 6. And now y sub 1 here, that number is going to be 13, correct? So I plug in all the things that I know. And now I'm going to use that relationship that I said. If these ordered pairs are equal, which is what this relationship here is saying, they got to be equal. Then that means the 3, the x-coordinate over here, has to be equal to the x-coordinate over here. So 3 has to equal 6 plus x squared over 2. There, can we solve for x sub 2? I said x squared. It should be x sub 2. Can I solve for that? Can I multiply both sides by 2? So multiplying both sides by 2. That would cancel with that. Come over here, multiply by 2. I get 6 on the left-hand side, right? Kind of running out of room here, but this would give me, come over here, it would give me 6 equals 6 plus x sub 2, right? How do I solve for x sub 2? Subtract 6 from both sides, right? So 0 is equal to x sub 2. There's my x-coordinate of my midpoint. Or not my endpoint, my other endpoint. Okay? Now I'm going to do the same exact thing over here with the y's. This negative 10, that's the y value of this ordered pair. It has to be the same as the y value of that ordered pair. So I take negative 10, and it has to equal 13 plus y sub 2 over 2. Again, multiply both sides by my denominator of 2. So they cancel over here. So give me negative 20 on the left equals 13 plus y sub 2, right? Subtract 13 from both sides. And there's my y value of my other endpoint. So I get 0 as the x-coordinate, negative 33 as the y-coordinate, and that is my other endpoint. Okay? That's kind of like the other day when we did the distance formula. We did the distance formula like, 10, 15, 20 times where we're looking for the distance, right? And then we did a couple problems where we were given the distance and we were looking for then a point, right? Or a coordinate. It's the same idea. We do the midpoint formula directly as x1 plus x2 over 2, comma y1 plus y2 over 2. We add x divided by 2, we add y divided by 2. We do that 10, 15, 20 times. And then we do a handful of these where we have to use the formula kind of in a different way. All right? And that's the approach that we're going to use to find that additional endpoint for that second endpoint. Is that okay? All right. I want to do at least one more. I've got because I think it's not necessarily just to reiterate what we're talking about, but to introduce a new idea. And it's question 14, I believe. I don't like the way the author of this presents question 14 because it's kind of hard to read. I'm going to zoom out. There we go. Okay, hopefully that speeds things up. All right, so this problem, like I said, I don't like the way that Math Excel asks us to graph these. You got to kind of maybe pop each one of these out or zoom in on them to really get an understanding of whether this graph is the one we're looking for or not. But I'm going to ask, these points are -3, -2, 1, -5. And so forth. But we got to pay attention. This happens all the time on the end of course exam, where that says -10 right here, correct? But how many grid lines do I have to get to that -10? I have 5. So each one of these grid lines is representative of 2 units, right? That happens a lot, and on the end of course exam, what they like to do for some reason is they'll make the x-axis go by 2s, and they'll make the y-axis go by 1s. Okay, so they just make you think and pay attention to detail. But I want to go through each one of these and see if -3, -2 is on there. So -3, okay, that'd be -3. So -3 would be right there. So that'd be -2. So -3 would be right there. -2 would be right there. Is that a point that I'm looking for? Is that on my parallelogram here? Nope. So it's not that one. I pop this one out. -3, -2 again would be there where my cursor is. That's not it. Pop this one out. Okay, -3, -2 does show up. Then I want to see, there's a couple other ways of doing this, but let's see if the other one has -3, -2 on it. This one does have -3, -2, so now I got to go back and decipher what other points are on here. So we've got 1, -5, so 1, -5, that's good. 3, 2, so 3, 2, that's good. And then -1, +5, so that's good. So this one does, C is the one. D would have some point on there that is not one of these 4. Is that okay with everybody? Oh, I messed up. So what I messed up on? -3, -2, 1, -5, right? That's good. 3, 2, and -1, 2, 4, 5, right? Why is that one wrong? They do look the same. -3, -2, 1, -5. Did anybody come across this in their homework and they look the same and one gave it to you is right? Okay. Oh, that's stupid. So there's an issue there with their programming then that shows that. If you know that happened to you and it's a big deal to you point-wise, let me know and I can go back and give you points for that. All right, so now it says find the midpoint of AC. Well, I'm gonna actually go to GeoGebra real quick, and so we have a better view of what's going on, because there is some final geometry here that I want to talk about that we use a lot in this course that this question presents. Okay, so Not sure whether you guys know what a diagonal is or not. We haven't talked about that based off a definition yet. But that segment right there would be considered a diagonal. A diagonal, by definition, is a segment that connects two non-consecutive vertices. Two vertices that are not back-to-back or one after another along a polygon. So it goes across the interior like that from D to B. Do we have the ability, if I know what point D and B's coordinates are, do you have the ability, guys, to find the midpoint between those 2 points I just highlighted over there? You can add the x's and divide by 2, right? So I divide those x's and divide by 2, what do I get? I get 0, right? Okay, now add the y's and divide by 2, I get 0 again, correct? Now this is just a unique situation based on the points that they provide us, but our midpoint for that blue segment becomes 0, 0. Okay? Some of the other examples we did today, that midpoint shows up somewhere else in the coordinate plane. Okay? But 0, 0 is a point, just like any other. We treat it like any other. Okay? So we've got that midpoint. Now the next question says, find the midpoint of the other diagonal. Well, the other diagonal is that red segment. Okay? And its endpoints are A and C, right? Can I take the x values of those, -3, and add 3 to it? -3 plus 3 divided by 2, right? Gives me 0 over 2, which is 0. Add your y's, -2 plus 2 divided by 2 gives me 0. So the midpoint of that red segment is also 0, 0. Does that make sense? Okay. So the next question then, guys, and this, so we did the math. We did the geometry, which is the calculations here, which is great that we can do that. But I think the more important aspect of a question like this, and the reason we do math, is so that we can ask and answer this question. What appears to be true about the diagonals of a parallelogram? Okay? What argument can we make? Now that we've got the data, now that we've got the values, what argument can we make? Okay? So if we look at these guys, I want to go back to the picture. By definition, that blue segment, does it pass through the midpoint of the red one? Okay, so when you have a segment, a line, a ray, or a plane passing through the midpoint of another segment, it is referred to as a segment what? Segment bisector. So the blue segment is a segment bisector of the red one, right? Okay. Let's change rules. Let's look at that red one. I'll look at the red one. Is it passing through the midpoint of the blue one? So is the red one a segment bisector of the blue one? Okay, so the red one bisects the blue one, and the blue one bisects the red one. So that tells us that those two things, based off the fact that they have the exact same midpoint, tells us that they bisect one another. And that's the geometry, that's the information that when you find the midpoint of two segments, and that midpoint is exactly the same point in both segments, you automatically have two segments that are bisecting each other. Does that kind of make sense? Okay. If I were to give you these points here, give you another image here. Let's say I give you -4, 2, and -1, -6. Okay. Then I give you C to be at 9.5, comma 2.5, and D to be at -14.5, comma -6.5. Okay, and I'll connect these again like I did previously. Go A and B, connect those, and then we'll go C and D, connect those. Make one of them blue. Okay, so I get those two segments. Okay, do we have the ability to look at AB, add those together and divide by 2, right? Add my x's together, gives me -5, right? Divide by 2, gives me -5/2, so -2.5. Take my y values, add those together, I get -4, divide by 2, I get -2, right? So that midpoint for that segment right there should be at -2.5, comma -2, right? is that the same midpoint that I get if I add those x's together? 9.5 plus -4, 14.5. If I add those together, it gives me 5, doesn't it? -5, right? Take that and divide by 2, you get -2.5. Take your y value, 2.5 plus a -6.5 gives you -4. Take -4 divided by 2, does it give you -2? So it gives me the exact same midpoint on the blue segment, right? What's that telling me about the red segment compared to the blue segment? They bisect each other, right? Okay. Let me do this. So the point E is the midpoint of the red segment. Let's find the midpoint of the blue segment, okay? And I'm going to make that point blue. Okay, let's make both of these a little bit bigger. And let me do this. I change things, right? They still cross through each other, don't they? They still intersect each other. The blue one's still going through the red one's midpoint, correct? But when I were to find both midpoints, okay, I find the midpoint of the red one, I get -2.5 comma -2. I find the midpoint of the blue one, I get that -5.35 comma -3.08 number. Okay? Because those are different ordered pairs, they don't bisect each other. Does that make sense? The blue one does bisect the red one. The red one does not bisect the blue one. Okay? And it's because they have different midpoints. If they have identical midpoints, they're bisecting one another. Is it okay? Okay? And that's something to think about when we classify something as a bisector, a segment bisecting another segment. It doesn't mean that I can always reverse it. Okay? So segment 1 bisects segment 2 does not automatically mean that segment 2 bisects segment 1. Okay? And that's something mathematically that we got to understand all the time in all of our rules. We can't just reverse roles and still get the same conclusions. We got to pay attention to that. Okay? Does that make sense to everybody? And that's what they're trying to get at in that question. We should be able to say the diagonals bisect each other. And that's going to be a fact that we see when we start talking about parallelograms again. Okay? We'll spend a lot of time on that property and dealing with the distance and midpoint formulas with parallelograms. I think it's chapter 6 actually that happens in. Okay. All right, so there are, with this one, there's 2 ways of approaching. Okay. The first way that I see, which I'm not going to make the argument that everyone's going to see this, because you might not be paying attention too much to the ordered pairs or what kind of values you get here. But when I look at that point there, or that coordinate and that coordinate, they're both the same, aren't they? And everybody, no matter what question I generate here, and we did this earlier today, this either becomes 6, a 4, or 2 for the most part. And this is then the same 6, the same 4, the same 2. So these x values are always the same. If we were to graph this, so 6, -11 might be down here. 6, -8 might be right there, correct? Those are the endpoints of that segment. Does that make sense to everybody? Okay. Sorry, mess that up. This is the endpoint. This is a midpoint. Okay. If I needed to find the other endpoint, okay, find the other endpoint. We know it's going to be up here somewhere, right? Do we know the coordinate or the x value for that ordered pair? What's it got to be? It's got to be 6, right? Every point on that vertical line has to have the same x coordinate 6. So I know endpoint number 2, let's call it E2, is going to have an x value of 6. Okay? Now, here's my other question. You know that distance right there, right? Okay, what's that distance from -8 to -11? Right? 3. Okay, so this distance here being, so this value, this y value here being -8, this would be -11. There's 3 units there, right? Okay. So what's going to be? The graph is right more like that up there. Doesn't matter. But if that's 3, doesn't that distance there have to be 3? Okay. So if this one was at -8, what does this one have to be at? -5. Does that kind of make sense? How you can walk yourself through that? Okay, with the graph, something like that. Now that can only be done, guys, if there's integer values, and I recognize that the x coordinates are both the same. So maybe you don't realize that. Maybe you don't think about going through that problem that way, and that is absolutely fine. Okay. Yesterday we said that the midpoint formula should be your catch-all. Okay. This formula where the midpoint, which is an x comma y, it's an ordered pair, is always going to be equal to the average of your endpoints as an ordered pair. I think a lot of times when we write equations like this, we lose sight of what we've actually got in front of us. The left-hand side here, this is an ordered pair, right? Okay? Now, they're arbitrary x's and y's, but the way we've written it, okay, it's an ordered pair. So this is an x value, that's a y value. Is this over here also an ordered pair? Yeah, it's an x value and a y value, right? If I have 2 ordered pairs in an equation like this, that sign right there tells me that these 2 ordered pairs are equal, right? How can 2 ordered pairs be equal? The only way they can be equal is if the x values are what's one another? The same. And then the y values are what's one another? The same. So if I gave you an ordered pair of 2, 7, and I told you, find me an ordered pair that is exactly the same or equal to that, you have to give me what? 2, 7. Okay? So that logic, that understanding hopefully allows us to realize that if this is x1, y1, and this is my midpoints ordered pair, x sub m, y sub m, okay? Can I start plugging that stuff in? Can I say x sub m right here is 6, and y sub m is -8? Does that make sense? Equal to, do we know what x sub 1 was? X sub 1 was 6, right? Plus then my x sub 2, which I don't know. That's the other endpoint that we're looking for here. The other endpoint is an x2, y2. We're looking for that. We don't know what it is. And now I can go back to y1 being -11, plus then my y2, which I'm unsure about what that value is, divided by 2 then. And here's the argument. If you told me that this is an ordered pair on the left-hand side, and this stuff is an ordered pair, they have to be equal, doesn't it mean that 6 needs to be the same as that? So we write that 6 is equal to 6 plus x sub 2 over 2. What can I do to both sides to start working that? Okay. Multiply by 2. 12 is equal to 6 plus x sub 2. Subtract 6, right? Okay. So I got x sub 2 to be 6, right? That's my first value for that ordered pair. Now I'm going to do the same thing, but do it for y. So that value there and that value, those coordinates have to be identical. -8 is equal to -11 plus y sub 2 over 2. Multiply both sides by both sides by 2. -16. So -11 plus y sub 2. Add 11. Now I get my y coordinate. And that's the same thing we found kind of using the picture, right? Using that first procedure. Which is nice because now if I am stuck, if I am confused, or I'm uncertain tomorrow, or any point on a quiz or a test, and I now understand that there might be 2 approaches here. If I get the same answer using both approaches, does that tell me I've done something right? Yeah. If I use both approaches, one approach gives me 6.85, the other approach gives me 2.5, something's amiss. Okay, maybe we gotta sit back and think about what we're doing. Okay, I want to do another one. I want to do one just very similar like 17. Okay, so 18, pretty similar, asking us for the other endpoint, okay? So they're asking us for what the x sub 2, y sub 2 is. That's unknown. Okay. It says the coordinates of point T are 2, 16, so there's my x1, y1. In the midpoint, it'll define what we're calling it, like whether it's point M or point E or whatever. We know it is the midpoint, so it's x sub m, y sub m. The reason here is why I would use the midpoint formula right away is because I don't have a graph, and I don't want to draw a graph, because drawing a graph is going to be time consuming, okay? Especially with value as big as 16. I don't want to go out that far on the x-axis, y-axis, that kind of stuff. The other issue is there's not a relationship between the x's and y's, like question 17 had a relationship between the x's, right? This is not a vertical line or a vertical segment or a horizontal segment. So the best thing to do here is to turn to the formula. This will always work. So our midpoint is going to look like this. This is the formula. Always write this down when we're doing these problems. And now we can substitute. We can say x sub m was 1. Y sub m is negative 10. X sub 1 is 2. X sub 2, that's what we're looking for. That's my variable. And then my y sub 1 is 16. Y sub 2, that's my other variable. That's what we're looking for. All over 2. And then we make the link. If these two things are ordered pairs, both sides are ordered pairs, we should be able to say 1 is equal to that stuff, right? So right now, 1 is equal to 2 plus x sub 2 over 2. And at the same time, I should be able to say negative 10 is equal to that stuff. So get negative 10 equal to 16 plus y sub 2 over 2. So if I set those up, my hopes are, guys, that we're at the level of algebra right now that going through those, solving those is not the task that's making us miss this. Okay? We should be able to go through and say this is 2 equal to 2 plus x sub 2, right? Subtract 2 from both sides, x sub 2 equals 0. Here I get negative 10 equals 16 plus y sub 2. A lot of times when I get this equation from people, they write down that the answer is like negative 6 or positive 6 or something like that. What is the actual value here for y sub 2? Negative 26, right? I have to subtract 16 from negative 10. And that's what happens. A lot of people think, they type something in wrong and get back to the answer wrong. They do it 2 or 3 times, but they bring me their work, and their work is everything up to right here. They got everything right, but then they subtracting negatives. Okay, becomes a problem for them. So just be careful. And that's why I like you guys to have notes out. I like you to have as many examples that you can possibly have. And when you're doing your homework, you're not just sitting on a calculator, typing something on a calculator, right? You're doing it by hand so that when you do get it wrong, you can go back and look at the data and analyze what you have done and recognize where you've made your mistake, right? If I do everything on my calculator, what happens when I turn my calculator off? Or I go to another calculation, all that junk's gone, right? I can't go back and analyze it and say, this is what I was doing wrong, this is what I was doing right. If you write it down, it's in front of you, you can always go back the next day, the next week, 2 weeks, 3 weeks from now, and look at that, analyze it, and try to maybe relearn it or reteach yourself if you need to. Okay? Is that all right? The more you guys write down, I know, I've been in the same situation, okay? When I take classes, I don't want to write a bunch of stuff down. It's time consuming. It's pain in the butt. I hate writing things, okay? But the more that you do of that, the more successful you're going to be. You give yourself a fighting chance, okay? But if I don't have anything written down, it's going to be problematic, okay? And you're going to find that out here pretty soon we start doing proofs. Okay. There are times when I let you guys use anything that you've written in class on tests and quizzes. If you haven't written anything down, are you hampered in comparison to the person beside you that's writing everything down? When we do proofs, you will be. Okay? So the more that we write down, the more that we do, the more information that we have in front of us that we can go back and look at and analyze, the better we're going to be setting ourselves up. Okay? The better success rate we'll have. All right? Does that help going over those questions? I want to do one more, and it's kind of it's an ugly one. It's question 14. It's ugly because I don't like the way that they present you the first couple, or the first question. They give you these 4 graphs. You got to pick out which one it is. I think it's ugly because we look at those graphs. They're all 20 by 20 graphs. You go from negative 10 to positive 10 on the x-axis. But their grid lines there's only 5 grid lines from 0 to 10, right? Meaning that every grid line is representative of 2 units, correct? So a lot of people will try to start plotting things and not pay attention to that, and it throws everything off, okay? Same thing happens on the other course exam. A lot of times the other course exam will give you an x-axis that is in a different scale than your y-axis. So maybe the x-axis goes by 2, and the y-axis goes by 1, okay? We want to pay attention to those things as we're going through. Another issue that we saw, and we only saw it last period, but I got a question when we were plotting these points, and you guys can reaffirm if this happened to you. And I thought C was the answer. I went through, I checked them all, C worked. They were all validated. I clicked C and said I was wrong. I opened up D. D was the exact same picture. D was right. Anybody, that happened to anybody? Did happen? Okay. So I understand that that's a problem. That's an issue with this question, and I'll send them an email about that so they can get that fixed. But when we go through this one, I'm looking for. It looks to me like all these graphs are different. Okay, so I don't think we'll run across that issue in this one. But if I pop these out, this is kind of the pain in the butt thing of these questions. -3, -1. So -3, -1. So this is 2 right there. This would be -1 where my cursor is. Does that make sense? Or -3 where my cursor is. Does that make sense? Because we're going by 2s. Well, -3, -1 is not on that graph, so option A is not what I'm looking for. I need this point right here. I need that point to be down here in the 3rd quadrant, right? So I'm going to try to figure out, there's a point in the 3rd quadrant, there's one in the 3rd quadrant, and there's one. So one of these might be, I'm going to pop out this one. I think this one's probably the best one. -3, -1. That's a point that I'm looking at. 2, -4. 2, -4, that's good. 6, 3. That's good. And the next one better be, what, 1, 6? And that's what we've got. So my option C is the right answer, okay? Now the next question says, now this is where I really wanted to get to with this, okay? It says, what is the midpoint of AC? So I'm going to do this in GeoGebra so we can look at the picture a little bit better. So we've got the point -3, -1, 2, -4, 6, 3, 1, 6. All right, so they say that these are the vertices for a parallelogram. Hopefully you guys know what that is. We'll talk about it at some point in this course. But both pairs of opposite sides are parallel, okay? They then say, can you look at the diagonals? Okay? This is a diagonal. Okay, that red segment is a diagonal. And by definition, a diagonal is a segment that connects non-consecutive vertices of a polygon. Okay, non-consecutive means, consecutive means back-to-back, right? Okay, so Monday, Tuesday, consecutive days. Monday, Tuesday, Wednesday, consecutive days. But Monday, Wednesday, Friday, we skip days, right? Yeah, they're not consecutive. So that's kind of the idea here. A and D, they're consecutive. They're one after another. A and B, they're consecutive, they're one after another. But A to C, see how we had to skip over D or skip over B to go from A to C? So those are non-consecutive. So that's a diagonal. Okay. They ask you to find the midpoint of that diagonal. Well, that should be something that we can do. We've talked about how we take those ordered pairs, A and C. We add the x's, right? So we got -3 plus 6, and we'll divide that by 2. Then we add the y's. -1 plus 3, divide by 2. And that gives us the ordered pair of 302, comma 1, doesn't it? Is it okay with everybody? And if I plot that, 3/2, comma 1, it puts that point right there. Okay, right there on the midpoint of that segment. Verification that we've done things correctly, right? Is that okay with everybody? The next thing they ask you to do is find the other diagonal. This is your other diagonal. Okay? And they actually find the midpoint of that one. So we're looking at D and B here. So point D, point B. Okay? And look at those 2 points. Add the x's. 2 plus 1, divide by 2. Add the y's. -4 plus 6, divide by 2. When I do that, what's 2 plus 1 divided by 2? It's 3/2 again, right? -4 plus 6 divided by 2, 1, right? The midpoint of the red segment is the same as the midpoint of the green one, right? Okay? So, that's some math, right? That's some calculation stuff, geometry stuff. But the next question they ask you, I think, is the important math, or the more purposeful math. Because now they ask you, and I'll type this stuff in, something to pay attention to as we're doing this. Guys, it says type in order pair. Does it tell me how to type my numbers? No. Sometimes it'll tell me use integers. Sometimes it'll tell me use decimals. Sometimes it'll tell me use fractions. It doesn't tell me, so guess what? It doesn't matter, right? So I can type in, 1.5, comma 1. Okay? And then the next one, maybe just to prove that it doesn't matter because it didn't tell me, maybe I go 3/2, comma 1. And it accepts both versions, right? Okay? But now the important part. What does that information tell me? Yes, I can use a formula, and I can get these midpoints and their locations, all that stuff. But when I get 2 midpoints that are the same here for these 2 segments, now what does that math tell me? And that's what I'm interested in. That's what we should be interested in all across mathematics. It's not, can we be calculators? Can we apply formulas? Because that's part of it. But when we get a result, and we get a relationship at the end, what does that relationship tell me? And is that a relationship that's consistent all the time? Okay? So it says, what appears to be true about the diagonals of a parallelogram? Well, we got all these options. Let's go back to the picture. If that red segment is passing through the midpoint of the green one, right? So E is the midpoint of the green segment. The red one is passing through that. So by definition, we have a line, a segment, a red, or a plane that is passing through a segment's midpoint. It is said to be what of that segment? Say again? Okay, get close. It's a bisector, right? But it's a segment bisector. When a line, a ray, a segment, or a plane passes through a segment's midpoint, it is then referred to as a segment bisector. So, that red line is passing through the green line's midpoint, right? So the red line, or the red segment, is considered a segment bisector. Is that okay with everybody? Meaning the red one bisects the green one. Okay? Does the green one do the exact same thing for the red one? Does the green one pass through the red one's midpoint? Okay, so the green one is the red one's segment bisector. Okay? So what does that tell me? It tells me they're both bisecting one another. Does that make sense to everybody? And the nice thing about this, the way that we could check this all the time, 100% of the time, if I want to see if two segments in the coordinate plane are bisectors of one another, I find both their midpoints. And if their midpoints are the same point, then they bisect one another. Does that make sense? Okay. Here we're seeing that 3 halves count 1, 3 halves count 1 are the same point. So we've got two bisectors. If I give you this, information, if I say point A is at -4, 2, B is at -1, -6, C is at 9.5 or 9.5, comma 2.5, and D is at -14.5, comma -6.5. Oh, 5. And we look at these segments. So that segment there, that segment there. And I'm not going to go through the algebra to show this, but if I asked for the midpoint of the green one, it's right there at E, right? Does that make sense? Okay. So I'm going to make that green, make it a little bit bigger. And now I'm going to ask for the midpoint of the red one. And we'll make it red. And we'll make it bigger. So you see the green one and the red one, those midpoints were on top of each other, right? So because those 2 points showed up on top of each other, that tells me that the red segment is a segment bisector for the green segment, and the green segment is a segment bisector for the red one, because they share the same exact midpoint. If I do this, okay, is one of those things still a segment bisector? The red one is a segment bisector, right? The red one goes through the midpoint of the green one. But the green one is not a segment bisector of the red one. Does that make sense, everybody? And how can I prove that mathematically? I look at those midpoints, and one of those midpoints is not the same as the other, right? If I were to use the midpoint formula on both those, we show you what GeoGebra gives us here. E and F are these points. Okay, so there are those 2 points. You see that those 2 points are obviously different, right? Okay, so that would be the math that tells me that I know certainly those things are not bisectors of one another. Okay, when you have a segment bisector, okay, it is bisecting that segment. It doesn't mean when I have a segment bisected, it does not always mean that the segment that is getting bisected, and the segment that's doing the bisecting is getting bisected. Does that make sense? Okay, that's a lot to say there. Okay, but I know that red one is a segment bisector. That does not automatically mean that the green one is a segment bisector. It only means that the green one is a segment bisector when they share the same midpoint. Okay, is that all right with everybody? It's this idea, an analogy like this. If I'm a daughter, she is my daughter, okay? But what am I to her? Am I her daughter? No, okay? So just because something's a bisector doesn't mean that I can reverse roles and say that the thing being bisected is also bisected, all right? Okay? I'm her father, she's my daughter. Those rules stay that way. They can't be reversed, okay? Keep those things in mind as we go through the course, because a lot of people want to see a rule and reverse it automatically and say that I get this result too. You can't do that. Okay? Some things you can, some things you can't. Okay? Just understand bisectors, segment bisectors are not one of those things you can reverse. Okay? Alright. That's all I've got for you guys today. Unless you have other questions, individual questions, you can come see me, we can talk about them. I will post this video. It's going to take a while for it to